Okay, class, we're about to start section 2.4, which is stated here in our syllabus, starts on page 151 and also page 158. Now, on page 151, we have lesson 2.4, which is the Great Tech Battle. Our learning objectives is to decide if two data sets are linearly related, find lines of best fit for data using spreadsheets and calculators, use lines of best fit to analyze data, and to interpret correlation coefficients. Now we will move on to problem number 2. Now I took the liberty of filling out problem number 2's graph to expedite time. It says, is there a relationship between the total fat in a fast food sandwich and the total calories? Begin your study of this question by drawing a scatter plot based on the table. Now, if you look here at all the points that were plotted, we have the x-axis, which is gram of fat, and the y-axis, which is calories. And I plotted each of these points, and if you notice down the y-axis, it goes by 20s, and the x-axis goes by 1. So then I drew the line of best fit, what I determined what was best fit, and if you notice, it really doesn't hit that many of the actual points. So for number 3 actually was this line that I drew, but I will read number 3. It says the points on your scatter plot don't form a straight line, but there should be a linear trend you can observe. Use a straight edge to draw a line that you think looks like the best fit for your scatter plot. Note that it's possible that the line that fits the data best doesn't go through any of the points. Now listen, your line may be different from my line. There's no set way to draw this line, but it has to look like a line. Okay, now we go over to page 153, and it says here, now that we've been able to draw a line that seems like a reasonable fit for data, it would be nice to find the equation of that line so we could do some calculations with it. We'd really like to use all the available points to find a line to model our data, but we'll need some technology to pull that off. In the meantime, we can use a relatively simple but useful procedure to find the equation of a line when you know any 2 points on the line. In the last lesson, we used the form y equals mx plus b to describe the equation of a line. This allows us to find the equation of a line when we know the slope m and the second coordinate of the y-intercept b. But what if we don't know the y-intercept? We can still find the equation. We just need a little ingenuity. A procedure for finding the equation of a line through 2 points. Step 1. Find the slope using the slope formula. Difference of y coordinates divided by difference of x coordinates. Step 2. Substitute the slope and the x and y coordinates of one of the points m for x and y in the equation. Y equals mx plus b. This results in the equation you could solve to find b. Now number 4, it says pick 2 points on your line. Watch out, don't pick points from the table or the scatter plot. Actually look at the line you drew and find points on the line. Write your points here. Now the 2 points I picked was 10 and 320, 20 and 460. So let's take a look. When I go here to 10, it goes up to 320. When I go to 20, it goes up here to 460, which is the points we have. Now I will tell you this, I did record this video earlier, but I made an error, so I'm re-recording this video. Okay, for number 5, it says use your points from question 4 to find the slope of the line you drew. What does it mean? Okay, the slope, you would take the difference of the y values, 460 minus 320, which is actually 140. So this would actually be 14. And then 20 minus 10, which would be 10. So it would be 140 over 10, which is 14. The line estimates an extra, it should be 14 calories for every extra gram of fat. Now, for number 6, It says pick one of your points from question 4 using y equals mx plus b. Substitute in your slope for m, the x coordinate of your chosen point for x, and the y coordinate of your chosen point for y. Solve the resulting equation to find b. What does it mean? Remember, b is the y coordinate of your y-intercept. So we picked one point, which would be 10, 320, and we also would take our slope, which is 14. Now we take our y equals mx plus b formula, and we substitute in these values. Y is 320, your slope is 14, and your x is 10 plus b. So it'll be 320 is equal to 140 plus b. Now, we'll write this over here because I lack the space. We will subtract 140 on both sides. So this will be 180 is equal to b. So when we write out our formula here, it will give us So after we get this, the formula that we would get would include the slope and the y-intercept. However, they want us to write what does this y-intercept mean in this problem. So the line estimates that a sandwich with 0 grams of fat would have 180 calories. Okay, number 7. It says use your answer for questions 4 and 5 to write the equation of the line you drew in the form y equals mx plus b. So it'll be y is equal to, the slope is 14, so it'll be 14x plus 180. So this would be your equation. So now we go on to problem number 8. It says, use your equation to predict the number of calories in a Whopper, which has 39 grams of fat. So you'll have y is equal to 14x plus 180. So y is equal to 14 times, the Whopper has 39 grams of fat plus 180. Now, we could put this in our calculator. So we could take 14 times 39 plus 180. And that would give us 726 calories. Now, we go down here to the next problem because according to our syllabus, we are supposed to go up to problem number 13 in this section. Now, below here, we're going to try and find the line of best fit. Now, you could read all of these directions at your leisure, but I will go through this step by step for problem number 9. It says here for problem number 9, it says use the procedure in the using technology box to find the equation of the line of best fit using a graphing calculator. Round to 1 decimal place. Okay, so this is what we need to do. We need to go to our calculator and we will press the stat key. You'll press enter, go up and clear out L2, go down, go to the right to L1 and clear out L1. Now we have to go back to page 152. And we need to enter in the values that we have from this table. Now, the grams of fat will be our L1 or our X value, and the calories would be our L2 or our Y values. So it'll be 9, 13, 21, 30, 31, 31, 34, 25, 28, 20, and also 5. Now we'll have 260, 320, 420, 530, 560, 550, 590, 500, 560, 440, and finally 300. Okay, now, after we've entered in all of these values and made sure that they were all correct, our next step would be to press Stat again, go over to Calculate, and go down to Linear Regression, which is number 4, and we will press Enter until it calculates. Now this is our equation. This will give us y is equal to, now instead of saying mx plus b, the calculator has ax plus b. So your a is actually your m. So they want us to round to one decimal place, so it'll be 11.7x plus 193.9. So this would be your equation. Now we go to problem 10. Use your answer to question 9 to predict the number of calories in a Whopper, which has 39 grams of fat. How does the answer compare to the answer of calories predicted by your own line of best fit in question 8? The actual number of calories in a Whopper is 660. So we would take y equals 11.7 times 39 plus 193.9. Now we put this in our calculator, it would give us 650.2 calories. Now, according to what my line estimated, we can go back here to the graph I did. It says at 39 grams of fat, my line estimated about 690. So my line estimated 690 calories, which is a bit higher. Okay, now we go down here because I believe our last problem is supposed to be 13. It says when finding the line of best fit using a graphing calculator, the last line in the display should be a value for quantity labeled R, which is known as the correlation coefficient. This number measures how well the line seems to fit the data. The closer R is to 1 positive slope or -1 negative slope, the more accurately the data you enter can be modeled using a linear equation. Here are some examples based on data from 2 of my classes last semester. One of these scatter plots has a correlation coefficient of 0.12. The other has a correlation coefficient of 0.72. Discuss which you think is which and why. Okay, now, the value that's closest to 1 will look more like a line. So basically here, this is the homework score, and this is the alphabetical position. Okay, now, it said, so basically, the first graph, which is closest to a straight line than the second graph, the first is 0.72, and the second is 0.12, because, again, the first graph has more of an increase in value, and and looks more like a line. Okay, now we go on to problem number 12. It says one of the scatter plots has each student's homework score for the semester on the x-axis and the corresponding overall percentage in the course from 0 to 100 on the y-axis. The other again has overall percentage on the y-axis, but along the x-axis is the student's position alphabetically in the class. The student whose name comes first alphabetically is 1. The next alphabetically is 2, and so on. Which plot is which? Label the x-axis for each graph. Again, discuss your reason. We actually did that earlier here. The homework score is this first graph, and the alphabetic position is this graph. Because remember, with the homework score, there's a fluctuation here with the different scores here. But with the alphabetic position, I mean, we only have 26 letters of the alphabet, and we know also that you're not going to get all 26 letters in a common class. They're going to be more grouped together, which it is here. Okay, so for problem 13, it says, which is the value of the correlation coefficient R for the fast food sandwich plot? Round to 2 decimal places. If your calculator is not displaying R, press second 0. Okay, now, this is what we would do. As you see here on my calculator, it's displaying the R squared and R. If your calculator is not displaying that, this is what you would need to do. You would need to press second and 0, and then we could just press down until we get to diagnostic on. Diagnostic off comes first, but we'll go to diagnostic on and press enter twice until you get the word done. Now you will go back to stat, then to calculate, linear regression, and hit it until it calculates it. Now your R squared, or your R, is 0.97. And that is your final answer. Now, we're going to move on to problem number 1 on page 158. However, there is one little problem. For problems 1 through 9, this is something that you would need to do in class with your group. I cannot actually do this for you because you all are supposed to work within your group, getting the shoe size of the people in your group and also the height. So problems 1 through 9 you need to do together as a group. So we're going to skip over to problem number 10 on page 160. Okay, now on page 160, problem number 10. It asks us here, we have the Olympic long jump. Now, the table to the right shows the gold medal lengths for the men's Olympic long jump for selected years from 1900 to 2000. When dates are part of a data set, it's common to not use the year, but rather the number of years after the first date. This allows for smaller numbers in the calculation, which can reduce the amount of rounding error. It says use a calculator or spreadsheet to draw a scatter plot for the data with the number of years after 1900 on the x-axis and length on the y-axis. Then find the equation of the line of best fit. Round coefficients to 3 decimal places. Okay, so basically they're asking us to do the same thing we did with the last problem that we covered, where we basically find the linear regression. So they ask us years since 1900. So this would be 0, 12, 20, 32, 48, 60, 72, 80, 96, and 100. So this right here, and it's already stated here, I didn't notice that, but that's good. This was stated here as our x value. This length would be our y value. So we would go to stat, press enter, clear out our L1 and L2, and then our L1 would be 0, 12, 20, and so on. Okay, now we will go to the left. We have 7.18. We have 7.60, 7.15, 7.64, 7.82, 8.12, 8.24, 8.54, 8.50, and finally 8.55. Now, next step, we will go back to Stat, go to Calculate, then the number 4 to get our linear regression, and then we have our formula here. It tells us to round the coefficients to 3 decimal places, so it'll be y is equal to 0.015 x plus 7.179. So that will be our equation. It says find the slope of the line. What does it mean? More detail equals better. Okay, the slope or our m is 0.015, and this is the winning jump increases by an average of 0.015 meters per year. Okay, number 12. It states here that the second table lists the length of the winning jumps for some years not in the table. Use your equation to find the predicted length of each winning jump. Okay, so basically what they're doing here is we're supposed to do, this would be 84, 104, 108, and 112. So what they want us to list is the predicted jump. Now this right here is the actual amount. So to get our predicted jump, we can go to y equals, clear this out, and we could type in the formula that we have, which is the y equals 0.015x plus 7.179. Now we could go right here to our table, and actually we can, well, first let me make a quick little adjustment here. We can go to auto and then go back to our table, and we need to get year 84, 104, 108, 112. But this would be a good time for me to reiterate how we could type in the X values. So we could do this. We could go to second, window, go down here to ask, and then go to second and graph, and we could type in these values here. We could type in 84, it'll give us the Y value. Then this would be 104, 108, and 112. So now we have all of our values. Let me move this up a little bit so I can include the calculator. Now, what we would do here is we will put our predicted jumps. So at 84, it would be 8.439. At 104, it would be 8.739. At 108, it would be 8.799. And then 112, it would be at 8.859. And we know the years 1984, 2004, 2008, and 2012. So these will be our predicted amounts. It says, how do the predictions compare to the actual jumps? So basically, how can you conclude after 2000, the equation is over predicting by quite a bit. The trend seems to have changed after 2000, with the winning lengths increasing more slowly. Okay, now with problem 14, it says use your equation to predict the year that the men's long jump record will reach 9.0 meters. Remember, the Olympics are only held every 4 years. So we will have our equation, y equals 0.015x plus 7.179. So we will substitute in 9 for y. 9 is equal to 0.015x plus 7.179. Now, we will subtract 7.179 on both sides. So that would give us 1.821 is equal to 0.015x. We divide each side by 0.015, and that would give us x is approximately 121.4 years. So this would be the year 2021, but there is no Olympics in 2021. So it would be the 2024 Olympics that this is predicting that it'll be a 9-meter jump. And that is the end of this section.